can't store it. We live in an era where the electrical grid we have pretty much across the world is still the same that Edison and Westinghouse and Tesla developed. Today, Edison would recognize our energy infrastructure. When we generate extra electricity and there is no demand, it gets dumped in the ground. So storing electricity is a big problem, is a big challenge, and that's another area of innovation. The big majority of solar installation today are done with silicon, polycrystalline and single crystal silicon. So efficiency and cost, so cost has come down, efficiency has gone up. There's a limit to efficiency with silicon. Cost, there's been some innovation on how to lower the cost even further with silicon, making thinner silicon wafer, using what I would call new manufacturing methodology for decreasing the cost of the material for silicon. But that's one area of innovation. Another area of innovation is actually using new materials, using other type of photoconverters. So you have material like gallium nitride, you have material like CIGS. You have materials that are now much more suitable to doing flexible. So one is gallium arsenide, so GaAs. The other one is CIGS, big capital letters. It stands for copper indium gallium diselenide, CIGS. And flexible is a big deal. So flexible is a big, important form factor for these materials, so that you can now, instead of having just flat plates on the roof, you can now think about having, on top of the cars, for example, places where you have curved surfaces, right? You also have material that are solar material that are being developed that are liquids, so you can coat on a piece of glass. And then you can arrange the cells on a piece of glass so that they're semi-transparent, and then you put that up in a building. So that's a true goal of what is called BIPV, Building Integrated Photovoltaics, is the ability to have these giant sheets of glass of all these giant buildings, being able to generate, let 60% of the light go through, and then the other 40% generate electricity with it. So energy storage is a wide category. When you think about energy storage, you think about the AAA batteries that you put into an alarm clock. That's one form of energy storage. You talk about lead acid batteries in the cars, right? Because even in car batteries, there's been innovation. We have now lead acid batteries that are completely sealed, that have a lifetime that is a lot better, that are maintenance free. Okay, that's one example. On the other side of the spectrum is how do you store a large amount of energy? And for that, you use what is called a flow battery. And a flow battery is a system that uses two kinds of electrolyte, literally hundreds and hundreds of gallons of electrolyte, which by themselves is completely inert and neutral. So they're not acidic, they're not corrosive in any way. They're just mostly water with electrolyte. But if you pick the right kind of electrolyte, and you have an interface, you can actually by flowing the electrolyte on each side, they don't mix with each other, but they're flowing on each side of the interface, you can actually draw currents. And you can recharge it, so they're rechargeable. So depending, if you want to recharge it, you just push current in, and the electrolyte gets charged a certain way. And if you want to draw power out of it, you just draw the electrons out, and the electrolyte gets discharged again. So it's an exchange, if you will, of valence states between the two electrolytes that allows you to get electrons in or electrons out. In a way, this is really simple. It's static. The tanks, all that technology exists. It's just stainless steel tanks and just pumping systems and energy density as a function of weight. Okay, so fuel cells. So lead acid is here. So you have a sense for what a lead acid is, right? You can store some amount of kilowatt per kilogram. It's pretty heavy because it's in the car. But you can see, for example, lithium ion batteries is 10 times the energy density, and it's 10 times the watt hour per kilogram. So it's like from a point of view of if you want a moving source of power, it's much better to have that. Now what's not on this is, for example, these flow batteries, but they would be probably pretty high power density per kilogram, but very low, very, very heavy. So they'd be somewhere around here, down over here.